Assalamualaikum. Today we're going to start with the chapter Numerical Solution of Equations in the P3 course. First of all, we need to understand what do we mean by the root of the equation. The root of the equation is when you solve for x in an equation. Okay. Now, root graphically means that if you have just one graph on the graph paper, the point of intersection of the graph with the x-axis represents the root. And if you've got two graphs on the graph paper, then the point of intersection of the two graphs is going to represent the root of the equation. Now, if I ask you to solve a linear equation like 2x minus 4 equals to 0, you can easily solve it. Or if it's a quadratic equation, x square minus 4x plus 8 equals to 0, you can easily solve it through breaking the middle term or using the quadratic formula. Or if it's a cubic equation, then also we can easily solve it. But there are some equations we cannot solve it generally. Okay, if I give you an equation which is e to the power 4x equals to 3, here also this equation you can solve with the help of the logs. Or if I give you a trigonometric equation like tan of 3x equals to minus 1.3, this can also be solved. But the equations which cannot be generally solved, for instance, if I give you an example, x square minus 10x plus e to the power 3x equals to 0. If I ask you to solve this equation, because it involves a quadratic equation, trigonometry, it also involves logs, so it is difficult to solve this question. In some of the cases, for instance, if I ask you to solve sec x equals to 3 minus x square, this equation can be solved graphically. That means you draw the graph of sec x and you draw the graph of 3 minus x square and see where are the two graphs intersecting, and the point of intersection of the two graphs is going to give you the solution. But not all equations can be solved through graph. Like this equation cannot be solved through graph. For this we use a method which is called iteration or the numeric solution of equation, which helps us to find out the root of the equation. Okay. One more thing which I want to explain is that, for instance, if I ask you to find out the root of a quadratic equation, assumingly this is the graph of the quadratic equation, and the graph is touching the x-axis at negative 1. If you take any value of x which is below this value, for instance, if you take x to be a negative 2, you will get a positive answer, and if you take x to be a 0, you will get a negative answer. Okay, so you should learn one thing right now, and that is before the root, any value before the root will give you if it's giving you a different sign, and of the value after the root, the value of x after the root is giving you a different sign, that means the root lies between these two values. That means in this case, in this particular case, the root should be lying between minus 1 and 0. Okay, so it can be any number in between them which can be the root. Okay, starting with the question. This is a general simple question of numeric solutions. The question says the equation x cube minus 2x minus 2 equals to 0 has only one root. Show by calculation that this root lies between x equals to 1 and x equals to 2. Whenever they give you the equation of a curve or a nonlinear equation or even a linear equation, and they ask you to find out, prove that the root lies between these two numbers, what you have to actually do is bring all the terms to one side. In this, all the terms are already on one side. Okay, so you don't have to make that effort. After you bring all the terms to one side, you have, in place of x, in place of 0, you can write y. So y equals to x cube minus 2x minus 2. After this, what you do is you plug in x as 1 and solve for it. Okay, let x equals to 1. So if I solve it, I'll get y 1 minus 2 minus 2, which is giving me a minus 3. Now I'm going to plug in x equals to 2, the other number which they have given you. So 2 cube minus 2 into 2 minus 2, which is giving me an 8 minus 4 minus 2, which is 8 minus 6, which is a 2. Now in this case I was getting a negative answer, in this case I am getting a positive answer. So using the same concept that before the root, if you're getting a negative answer, and before the root you're getting after the root you're getting a positive answer, or vice versa, that means the root should be lying in between these 2 points. So you can just write down a statement, and that is because of change of sign rule, the root lies between minus 3 and 2. Okay, For the second part, prove that if a sequence of values given by the iterative formula converges, then it converges to this root. Okay, what you have to do for this part is that they are saying that with you can either get the formula with the help of the root with this formula, or you can have the iterative formula. Iterative formula is the formula which helps us to find out the root with a specific method, which I'm going to teach you in the third part of the question. They are saying that if a sequence of values given by the iterative formula converges, then it should converge to this root. Okay, that means this is the iterative formula. What you do as the first step is you get rid of all n's here, because this is given to you in terms of n. X n plus 1 equals to 2x cube. You have an n here plus 2, 3x square, you have an n here minus 2. Get rid of the all n's first as a first step. So I'm just copying it here. Okay, for the second part, what I'm supposed to do is I'm going to get rid of all n's. Okay, after this, what I'm supposed to do is I'm going to rearrange so that I get the initial equation which they had given us. Okay, this is the iterative formula, and you rearrange it to get the original equation which they have given you. Okay, so I'm going to rearrange it. I'm getting a 3x cube minus 2x. I'm cross multiplying 2x cube plus 2. I'm shifting all the terms to one side. So 3x cube minus 2x cube is giving me x cube minus 2x minus 2 equals to 0. Okay, so see, I've got the same equation. So this is what you had to prove for the second part of the question. So it's proved. Now for the third part of the question, it says use this iterative formula to calculate the root correct to 2 decimal places. Given result of each iteration to 4 decimal places. What you have to do as a first place is you write down the iterative formula. Okay, and you have to use this iterative formula to get the root. Now in this question they have not given you the initial value. Generally they give you the initial value as to with which value of x you have to start, but in this case they have not given you any initial value. If they don't give you any initial value, then you have to take the root between these 2 points, because you know that the root lies between these two. So generally we take the midpoint of these two. So 1 x1 equals to 1 plus 2 divided by 2, which is a 1.5. So you have to take x1 as 1.5. That means with 1.5 you're going to start. Now you have to take the calculator in your hands. What you have to do is put 1.5 in the calculator and put an equals to sign. This way the calculator is going to store 1.5 in the answer. Now you write down this formula in the calculator, and in place of every x, do not write this, just write this. In place of every x you have to write, this is step number 1 for the calculator, where you have to write 1.5 and press equals to this, so that equals to sign, so that the calculator stores the value of 1.5 in the answer. Step number 2, you take this part, and in place of every x you have to write answer. 2 answer cube plus 2 divided by 3 answer square minus 2. So I'm writing this in the calculator. I'm writing 2 answer. Firstly I'm writing down the fraction, putting the fraction in the top. On the top I'm going to write 2 answer cube plus 2. In the denominator I'm going to write 3 answer square minus 2. Okay, once I'm going to press the equal to sign, after this I will get the value of x2. What you have to actually do in this case is that starting with 1.5, you have to plug in 1.5 into this. Whatever the answer is, that will become your x2. And then you have to plug in x2 into this and get the answer. That will become your x3. Then you have to put that value of x3 into this, and that will become your x4. You have to keep on doing this process and write down the answers up to 4 decimal places until your answer or the root becomes the same up to 2 decimal places. Okay, so this is my x1. I have pressed the equals to sign, and I'm getting x2 as, because I've already put this formula in the calculator, that means the calculator is taking answer as 1.5 and calculating it. So after putting 1.5 and writing down this formula and pressing equals to, the calculator is giving me the second value, which means the calculator is solving 2 1.5 cube plus 2 upon 3 1.5 square minus 2. And calculator is giving this answer as Calculator is giving this answer as 1.8421. I have to write down each answer up to 4 decimal places with rounding off. Okay, now that means x cube. I don't have to keep on putting, if you don't use this method, then you have to keep on putting this value in this once again and write it down again and again. So the better idea is to put equals to sign. After you've plugged in this formula, just press equals to sign once again, and you will get the value of x3, which is 1.7728 up to 4 decimal places. Now I'm going to press it again, and I'm getting 1.7693. Okay, I told you that you have to accept the answer which is giving you the same number of decimal places up to 2 decimal places. Like if I round this off up to 2 decimal places, I am getting 1.77, and if I round this also up to 2 decimal places, I am getting the same answer. That means the root is going to be 1.77, which you have to take as, and you notice that this root, which is 1.77, is lying between 1 and 2. Okay, coming on to this question. Okay, this was the simplest level of the question where they ask you to prove that the root lies between any two numbers. Okay, and you have to plug in those two numbers. After putting everything on one side and plugging in these two answers, and you will notice one of them is negative, one of them is positive. The second method is to prove that the formula converges to this. So you have to get rid of the n's and cross multiply and prove that the original equation is the same. That means you have taken out this formula from this original equation. Third part, you have to find out the root. Okay, in this second type of questions, they give you a figure and they ask you to prove something first, and then they give you the same parts after that. Okay, let's read this question. It says the diagram shows a curved rod AB of length 100. So this is the rod AB, which is of length 100, which forms an arc of a circle. The endpoints A and B of the rod are 99 centimeters apart. The circle has radius, they're talking about this. The circle has radius r, and the arc AB subtends an angle of 2 alpha radians at O, the center of the circle. Show that alpha satisfies the equation this. Okay. Now, if I notice, we have sine in this. Okay, so what I can actually do is I can make a right angle triangle. I can take this angle to be alpha because this whole angle was 2 alpha. This side can be taken, if this whole thing is 99, I can take this to be 99 upon 2. Okay, so I can write sine of alpha equals to 99 upon 2 divided by the hypotenuse, which is r. If I cross multiply, I can just simplify this sine of alpha equals to 99 upon 2 divided by r, meaning multiply by 1 upon r, which is 99 upon 2r. Okay, now I need to take help from something else also, because with the help of this I cannot prove it. So I have to take help from the length of arc formula. Okay, so the length of arc, we know S equals to r theta. We have this formula to find out the length of arc. Length of arc of a sector equals to the radius multiplied by the angle in radians. Angle of the sector in radians. Okay, I'm making use of this formula. Length of arc is 100 in this case. R is r. Theta is 2 alpha. Okay, I can make r the subject from here, because if you notice in the formula which they have given us, they have gotten rid of r from here. So I can make r the subject from here, which is giving me 100 upon 2 alpha, which is r is 50 upon alpha. Now I can plug in this r. I'm calling this as equation number 2, and I've called this as equation number 1. I can write substituting equation 2 in equation number 1. Okay, so r equals to 50 upon alpha. I can plug it into this. Sine of alpha equals to 99 upon 2 times r, and r we know is 50 upon alpha. Let's simplify this. Sine of alpha equals to 99 upon 100. Upon alpha. Okay, the denominator is 100 upon alpha. Let's simplify the sine of alpha equals to 99 divided by 100 upon alpha. So this will become sine of alpha equals to 99 multiplied by alpha upon 100. Sine of alpha equals to 99 upon 100 alpha. Now changing it in terms of x will give me sine of x equals to 99 upon 100 x. This is what we had to prove in the first part of the question. which we have proved. Now they're saying, given that this equation has exactly one root in the interval 0 to half pi, verify by calculation that this root lies between 0.1 and 0.5. Now we're going to take the same formula. Okay, if you have to prove that the root lies between any two numbers, what you're supposed to do is you bring all the terms to one side and make 0 on the other side. So I can write 99 upon 100x minus sin x equals to 0. In place of 0, you can write y. 99 upon 100x minus sine of x. This is the formula. Now you have to plug in the two values which they have given you. The first value is a 0.1 and the second value is a 0.5. Okay, let x equals to 0.1. Okay, let's solve this. 99 upon 100 into 0.1 minus sine of 0.1. Let's see whether we get a positive answer or a negative answer in this case. 99 into 0.1 divided by 100 minus sine of 0.1. This is giving me minus 0.00833. Okay, if I plug in let x equals to 0.5, because we have to prove that the root lies between 0.1 and 0.5. Okay, so it will become y equals to 99 upon 100 into 0.5 minus sine of 0.5. Let's see what do we get now. It's a 0.01557. This answer was a negative, then this is positive. Okay, therefore by change of sign rule, again you have to always write down the statement, change of sign rule, the root lies between 0.1 and 0.5. Okay, then we're supposed to after this you have to show that if the sequence of values given by the iterative formula converges, then it converges to the root given in part 1. Okay, what you have to do for this part is you have to take this equation, get rid of all n's from here. I'm writing down the equation. Get rid of all n's, so I would write x equals to 50 sine of x minus 48.5x. Rearrange this so that you get the original formula which was given to us in the question, which is this one. So with this we have to get this. What I'm going to do here is I'm going to shift all the terms with x on one side. So it's x plus 48.5x equals to 50 sine of x. Okay, x plus 48.5, that means 1 plus 48.5 is 49.5x equals to 50 sine of x. Sine of x equals to 49.5x upon 50. 49.5 divided by 50 is giving me 99 upon 100. So 99 upon 100 equals to sine of x. So proved. This is what you had to prove, that if this iterative formula, this formula converges, it is going to give you this iterative formula. So you have to go back and get to the same equation which they had given you originally. Now for the last part of the question, they are saying use this iterative formula with initial value x equals to 0.5 to find alpha corrected to 3 decimal places. Okay, so you have to use the iterative formula which I am copying here. X equals to xn plus 1 equals to 50 sine of x n minus 48.5 xn. Okay, they have given us the initial value which is 0.21. So what you have to do in the calculator, you have to write 1.5 and then you have to press the equals to sign. So the calculator is going to store 1.5 in the answer. Okay, what you have to do after this is, in the calculator, this was the first step. In the calculator you have to write down this formula. Okay, just this side of the formula. In place of every x you have to write answer. So it will be 50 sine answer minus 48.5 answer. Okay, so I'm putting this firstly I'm putting 1.5 and then I'm pressing the equals to sign. Then I'm writing 50 sine answer minus, after answer you have to close the bracket because it's sine answer, so the bracket has to be closed, minus 48.5 answer. Okay, once I'm going to press the equals to sign, okay, let me just quickly write it down again. 50s, just hold on. Okay, they had given us the initial value to be 0.25, so you have to write 0.25, not 1.5. Okay, so I'm writing 0.25 and I'm putting equals to sign, so this answer will be stored in my calculator. Now I'm going to write down this equation in the calculator, 50 sine answer, bracket close, minus 48.5 answer. Okay, so the initial value is coming out to be, we know that the value of x1 is 0.25. Now x2, how will we get? We're going to simply write it down. Just hold on. x1 is 0.25. x2, how will you get? You will plug it into the equation, 50 sine of 0.25 minus 48.5 into 0.25. So the answer for this is coming out to be 0.245 up to 2 decimal places. They're saying given the result of each okay, they're saying find alpha correct to 3 decimal places. Okay, showing the result of each iteration. So you should better take the value of each iteration up to at least 4 decimal places. So I'm rounding it off. I'm writing 0.252 here. Okay, now I'm going to press the equals to sign and the calculator is going to give me the value of x3, which is 0.2453 after rounding off. Okay, if you notice, this is also up to 3 decimal places. This is also 0.245 after rounding off, and this is also 2.5. So this is going to give me become my final answer. So the root of the equation is going to be 0.245. This is the final answer which I have. You have to keep on doing until you get the answer correct to 3 decimal places. Okay. While sketching suitable graphs, show that the equation sec of x equals to 3 minus x square. Okay, what you have to do is you have to draw a suitable graph. So that means you have to draw 2 graphs. One is the graph of sec x and one is the graph of 3 minus x square. This is a normal quadratic curve and this is the graph of the reciprocal function. Okay, for this, if in case you don't know how to draw the graph of the reciprocal function, you have to watch the video which is the graph of the reciprocal functions in the P3 course. Okay, once we know that the graph of cos x is this 2 pi here, pi by 2 and 3 upon 2 pi. The graph is going to become 0 at pi by 2 and you have to draw the graph of graph from 0 up to pi by 2 only. So if this is pi by 2 and this is 0, you will draw a dotted line here. Okay, wherever the graph of cos x is becoming 0, you have to draw a dotted line here because this is the graph of the reciprocal function. So now the graph is going to go like this. Okay, so if this is 1, the graph is going to become undefined here. I have drawn the graph of sec x. Okay, this is the graph of sec x. Now I have to draw the graph of 3 minus x square, and the two values which I am taking for x is 0 and pi by 2 only. So 3 minus 0 square is going to give me 3 only. So one value for if x is a 0, y is a 3. Another value which I am taking is pi by 2. If x is pi by 2, so 3 minus pi by 2 square is giving me 0.532. That means with pi by 2 I have to plot 0.532, which is this point, and with 0 I have to plot 3. This is the graph of the quadratic curve. So you just have to draw it till here. So this is enough. Okay, so you know that the two graphs are intersecting at this particular point. So there's just one root. This is the root. So just have to prove that there's just one root in this interval from 0 to half pi. Show that if a sequence of values given by the iterative formula converges, then it converges to a root of the equation given in part 1. What you have to do for this is that get rid of all the n's from here. So I'm writing x equals to cos inverse of 1 upon 3 minus x squared. If this is cos inverse, x equals to cos inverse of this, you can actually write cos of x equals to 1 upon 3 minus x squared. Like if I have cos of x equals to y, I can write x equals to cos inverse of y. So if I have to come back to this, I will write y equals to cos of x. This is what I am doing right now. Okay, what I'm going to do here is I'm going to cross multiply or do something so that I get this initial equation back. That means sec x on one side. Okay, if I want sec x on one side, that means I have to reciprocate it. So if I'm reciprocating this side, I'm going to reciprocate this side as well. So this will become sec x equals to 3 minus x squared. So this is what I had to prove for this part. So I'm done with the second part also. Now I have to do the next part, which says use this iterative formula with initial value x equals to 1 to determine the root in the interval 0 to half pi, correct to 2 decimal places, showing the result of each iteration. Okay, so you have to at least show the result of each iteration up to 4 decimal places and then final answer up to 2 decimal places. So what you have to do in this question is you have to write down the iterative formula with n's. Okay, so I'm just copying it here. And the initial value which you have to take in this case is 1. Okay, so you will write down in the calculator 1 and then you press equals to sign. So the calculator will store this value as answer. Okay, then you write down in the calculator, you write down this part of the formula. So you write cos inverse 1 upon 3 minus answer square. Okay, so this is what I'm doing. Cos inverse of fraction, on the top I'm writing 1, in the denominator I'm writing 3 minus answer square. Okay, so the calculator is giving me the first value as 1 point. So x1 we know is 1. x2 is going to be cos inverse of 1 upon 3 minus 1 square, which is 1.0472 up to 4 decimal places. Now I'm going to keep on pressing the calculator's equals to sign. So the next answer which I'm getting is 1.0176. You have to give the answer up to 2 decimal places. So up to 2 decimal places I'm getting 1.05 here and I'm getting 1.02. So I have to keep on doing until I get the answer correct up to 2 decimal places. The answers of 2 steps, any step and the previous step is the same. The next step is 1.0367. Here also up to 2 decimal places it's not the same. I'm going to once again press the equals to sign. 1.0246. This is also not the same. I'm going to press the equals to sign once again. I'm getting 1.0323. Once again if I press the equal to sign x7, I'm getting 1.027. Okay, up to 2 decimal places it's 1.03 and this is also 1.03. That means the root is going to be 1.03. This is the answer. Okay, let's do this one. By sketching a suitable pair of graphs, draw the graph of 2 minus x and ln x. I know this is a linear graph, so I can easily draw this. Okay, so if I just take a few values of x, if I take x as 0 and once if I take y as 0, so y equals to 2 minus x. Okay, so 2 minus 0 is going to give me a 2, and if I take y as 0, I will get 2 minus x. So x will become 2. That means I have to plot 0, 2 and 2, 0. 0, 2 is this point and 2, 0 is this point. So I can plot these two and I can make a graph out of this. This is the linear graph which I have already drawn. Now I have to draw the graph of ln after this. Ln x. We know the graph of ln x cuts the x-axis at 1. Okay, and y-axis is the asymptote to the graph. So the graph is going to be somewhat like this. This is the graph of ln x. For this chapter, you should know the general shape of all the graphs of ln x, for ln, for the exponential functions, the trigonometric functions, the reciprocal functions, all these. Now we have proved that the root lies between these 2 points. Verify by calculation that this root lies between 1.4 and 1.7. Okay, how will you go about doing it? You have to first bring all the terms to one side. Okay, so I'm bringing 2 minus x minus ln x equals to 0. In place of 0, I can write y now. 2 minus x minus ln x. Okay, I'm going to substitute the value of x as 1.4. Let x equals to 1.4. So I'm getting 2 minus 1.4 minus ln 1.4. Okay, I'm getting 2 minus 1.4 minus ln 1.4. This is 0.264. I'm getting a positive answer. Now I'm going to take let x equals to 1.7, y equals to 2 minus 1.7 minus ln 1.7. I'm getting a minus 0.2306. Okay, you can write therefore by change of sign rule. Since the sign is being changed, that means we know that the root lies between 1.4 and 1.7. The root lies between 1.4 and 1.7. Okay, so we're done with the second part also. Show that this root also satisfies the equation this. We're going to copy the equation and we're going to rearrange it so that we get the original equation back. Okay, so we're going to cross multiply 3 minus 3x equals to 4 plus x minus 2 ln x. If you notice in the original equation they have ln x on one side, so I'm shifting, making ln x positive. 2 ln x equals to 4 plus x minus 3x. 2 ln x equals to 4 minus 2x divided by 2. Ln x equals to 4 minus 2x divided by 2. Ln x equals to 2 minus x. This is what we had to prove for this part of the question. Okay, the next part they are saying use the iterative formula to find the root and you have to take the initial value to be 1.5. Use the iterative formula. Okay, you have to take the initial value to be 1.5. So x1 equals to 1.5. I'm writing 1.5 in the calculator, putting the equals to sign. Now the answer key has 1.5 stored in it. Now I'm going to write down this formula, just this side of the formula, and in place of every x I'm going to write answer. So 1 upon 3, then I have a bracket, and in the bracket I have a fraction. I have 4 plus answer minus 2 ln answer, close the bracket. So the first value x2 is when I press the equals to sign, I'm getting the second value, which is 1.4563. Third value is going to be, once again if I press the equal to sign, 1.5565. See, up to 2 decimal place, this is also 1.56 and this is also 1.56. So the result is going to be, the root is 1.56, which is the final answer. Okay, I'm doing this part. The diagram shows a semicircle ACB with center O and radius R. The tangent at C meet AB produce at T. The angle BOC is x radians. The area of the shaded region is equal to the area of the semicircle. Now you have to prove that x satisfies this equation. Now first of all, if I see tan here, that means I can use tan, do something to have tan first. I know it's a right angle triangle. Okay, so I can get the area of this triangle because it says the area of the shaded region is equal to the area of the semicircle. For the shaded region, I have to subtract the area of the sector from the area of the triangle. Okay, so I'm going to subtract the area of this triangle minus the area of the shaded region. But first of all, I'm going to get the area of the triangle. For that, I have the base, I don't have the height, so I have to find out the height. So I'm writing tan of x equals to, I'm calling this as y upon r. So if I make y the subject, because I need to get rid of y, so I will make y the subject and put it in the other equation. Y equals to r tan of x. Now, using this, the area of the shaded region, okay, area of shaded region equals to area of triangle minus area of sector. Area of triangle is half into base. Base is y, which is r tan of x, into height, which is r. Area of triangle minus the area of sector. Area of the sector is half r square theta. Theta is x in this case. We are using the formula area of sector equals to half r square theta. Okay, this is going to be equal to the area of the semicircle. The area of the semicircle we know is half r square theta. Half pi r square, okay, or you can take theta, because theta is going to be pi in this case. Get rid of r square from both the sides. So if I can just write it like this, half r square tan of x minus half r square x equals to half r square pi. If I get rid of half r square from both the sides, I'll be left with tan x minus x equals to pi. Okay, so tan x equals to pi plus x, or x plus pi. This is the answer. This is what you had to prove. Okay. Now, use the iterative formula x equals to this to determine x correct to 2 decimal places, giving the result of each iteration to 4 decimal places. Okay. What I'm going to do here for this, what I'm going to do is, I'm just copying the iterative formula. Okay, if I shift all the terms to one side in this case, tan of x minus pi equals to 0. If I plug in x as 0, let x equals to 0. So it will be tan of 0 minus pi. So it's going to be a negative answer, minus pi. Minus 3.142. If I take let x equals to 1, it will be tan of 1 minus pi. Let's see what is this answer. Tan of 1 minus pi. It's minus 2.584. Let x equals to 2. Tan of 2 minus 2. Minus pi. Okay, it's giving me minus 7.32. Okay, what you have to actually do is, if I take okay, just hold on. Instead of taking all the terms to that side, if I take it to this side, it will be x plus pi minus tan of x. X plus pi minus tan of x equals to 0. Okay, if I take x as 0, I will get pi in this case. Okay, if I take x as 1, I will get 1 plus pi minus tan of 1. I'm getting minus 3.699. Okay. One plus pi minus tan of 1, I'm getting 2.58 in this case. Okay, 2 plus pi minus tan of 2, I'm getting a 7.326. Okay. And since we know that this is defined, the value of x in this question should be between 0 and 1 only, because it's in the first quadrant. Okay, 0 and pi by 2. Pi by 2 is 1.57. Okay, pi by 2 is 1.57. That means the root should lie between 1 and 2. 0 and 2 only. Okay, so if I start with the initial value of x equals to say 1. Okay, if I take the mid value as 1, and if I take let x equals to 1. Okay, I'm putting 1 and I'm pressing the equals to sign, so the calculator has stored this. Now I'm going to write down this formula in the calculator: tan inverse of answer plus pi. Okay, tan inverse of answer plus pi in the same bracket. Okay, so I'm going to write tan inverse of answer plus pi. Okay, so the first answer which I'm getting here is 1.3338. Okay, this is the value of x2. x2 is 1.3338. Okay, x3 is going to be 1.35096. To up to 4 decimal place, it will become 3510. Okay, x4 is going to be, if I press it again, it is 1.3518. So up to 2 decimal places, this is also 1.35 and this is also 1.35. So the answer or the root is going to be 1.35. Okay. Coming on to this question, it says the equation x cube minus 8x minus 13 equals to has only one root. Find the two consecutive integers between which this root lies. Okay, you can start with 0. Let x equals to 0. Okay, everything is already on one side. Plug in x equals to 0. It will become 0 minus 8 into 0 minus 13. So the answer is a negative 13. Let x equals to 1. So if I plug in 1, I will have 1 minus 8 minus 13, which is minus 20. Let x equals to 2, it will become 8 minus 8 into 2 minus 13. 8 minus 16 minus 13, which is a minus 21. Let x equals to 3, it will become 27 minus 8 into 3 minus 13. That means 27 minus 24 minus 13. This is a minus 10. Let x equals to 4. It will be 64 minus 8 into 4 minus 13. So 64 minus 32 minus 13, which is a 19. Now if you notice, with x equals to 3 I am getting a negative answer, with x equals to 4 I am getting 19. So between x equals to 3 and x equals to 4, the root lies. The root lies between these two numbers. Use the iterative formula to determine this root correct to 2 decimal places, giving the result of each iteration up to 4 decimal places. Okay, now they have not given you the initial value, but you know that the root lies between 3 and 4. So you can take the value to be 3.5 also, but it's not necessary that the root should be lying after 3.5. So in this question, what you can actually do, you either take the midpoint and see whether it's converging or not, and if it's not converging, then you start from 3 only. Okay, so if I start from 3, or you can start from 3.2 or any number which is smaller than 3.5 if it is not converging from 3.5 onwards. So if I take x1 as 3, okay, I'm writing 3 and I'm pressing the equals to sign, and I'm writing down the iterative formula. What will I write in the iterative formula? In the calculator, I'm going to write 8 answer plus 13 to the power of 1 upon 3. So I'm writing in the bracket okay, I'm writing in a bracket 8 plus 8 answer plus 13 bracket close to the power of 1 upon 3. Okay, so the first x2 is coming out to be 3.3322. x3 is coming out to be 3.4102. x4 is coming out to be 480 if I round off. x5 is coming out to be 20. You have to give the answer up to 2 decimal place. Up to 2 decimal place, this is also 3.43 and this is also 3.43. So the root is going to be 3.43 in this question. Hope you have an idea as to how to solve questions with numerical solutions or iteration. Thanks a lot for watching the video.